Hi, everyone. Thanks for showing up for your learning. My daughter's shown up for her learning. Either that or she's shown up to escape bedtime. But here we go. She's going to learn some math regardless. Say hi, honey.
Hi.
So, when we have a problem like this and it says simplify fully and state restrictions, well, let's go for it. All right. So, the first step is to write an equal sign. I gave a lecture about why that's important in the last video. I'm not going to do it again. And then I'm going to actually copy out the architecture of the question here, like that. And then I'm still going to keep that as a division and get them factored so that I can state my restrictions. Okay. Now, x squared minus 12x plus 32. Again, this is an x game where I have 32 I want to multiply to, and I want to add to negative 12. Oh, those numbers are negative 4 and negative 8. Wasn't hard to find because there's only factors 2 for 32. You can only multiply multiples of 2 together to get 32. Okay, so that would be x minus 4 multiplied by x minus 8 would recreate this trinomial here. All right, now the bottom one, actually, we need to common factor that because there's this common factor x there. There's an x at least in each one, and 2 is a common factor as well. You want to very quickly look at those and see they're all divisible by 2. All right, so let's take those out. First, let's take out my obnoxious circles. And let's do it. So we're going to have 2x as our common factor, and that's going to leave x squared minus 9x plus 20. Multiplies to positive 20 and adds to negative 9. I know the numbers, but I'll tell you later. It's going to come up soon. X squared minus 1 is the difference of squares. So that factors as x plus 1 times x minus 1. Okay, x squared minus 7x minus 8. Well, that is x minus 8 times x plus 1. You can x gain these yourself if you want to or need to. And this one here, x squared plus 4x minus 5. Well, that will be x plus 5 multiplied by x minus 1. And then 25x minus
Is being a
25
teacher
minus x
fun?
squared. I enjoy it, honey. I have a good time. This is 5 plus x multiplied by 5 minus x. All right, cool. Now, next line equals, okay, let's scroll down a little bit. And now here, x squared minus 9x plus 20. Let's factor that. X minus 4 times x minus 8. All right, over 2x times x minus 5 times x minus 4. Since minus 5 times minus 4 is positive 20, and minus 5 plus minus 4 is minus 9, that's the correct factorization of what you have in the previous line. And then those don't change. I'm just going to rewrite them. X plus 1 times x minus 1, and then over here x minus 8 and x plus 1. Since I have everything factored now, I'm going to flip that fraction into 5 plus x multiplied by 5 minus x. Notice that if we're dividing by a fraction, we just flip the fraction and then multiply. And then on the bottom, we're going to have x plus 5.
What number is X?
Well, that's a question that students often ask me, Zara, and x is actually absolutely any number.
Really?
Yeah, except there are some restrictions on x that we should take note of right now. X cannot create a 0 in the denominator. So we can't have a 0 on the bottom of the fraction. So x is not equal to, well, can't be 0 because you see there 2x, that would make a 0, so it can't be 0. It can't be 5, and it can't be 4. See that? It can't be 5, can't be 4. So let's list those. 4, 5. It can't be 8. 8. It can't be negative 1. Negative 1. Okay. It can't be negative 5. And it can't be positive 1. So there's a list of all of our restrictions. But we also had these two factors that were in the denominator before we flipped them and they came up there. But if you notice, we already have those restrictions taken care of. We already have 5 and minus 5, so we don't need to add any more restrictions for those. That's a complete list of our restrictions. Let's keep going. Okay. Oh, right. Now we get to do the fun part. The canceling. So I have an x minus 5 on the bottom. Oh, why did I start with that? Jeez. We need to talk about that one. Ah, oh, gosh. Oh, those of you who are watching at home are just like, Mr. Jennings, come on, get a hold of yourself. Cancel in an appropriate way. X minus 4 will cancel x minus 4. Hurrah! X minus 8 will cancel x minus 8. Notice I can only cancel stuff that's on the bottom and then it's on the top.
That's
it's on
weird.
the bottom, it's on the top. X plus 5 is the same thing as 5 plus x.
This group right here is all x.
Yeah, they're all gone. That's the same thing. Why? 5 plus x equals x plus 5. No difference, right? I can do 2 plus 3 is the same thing as 3 plus 2. Doesn't matter. So that's the same. So I canceled those. But 5 minus x does not equal x minus 5. Doesn't equal. No, they're not the same. Because, 3 minus 2 is not the same thing as 2 minus 3.
Oh.
But if I factor out a minus 1 there, like I say, minus 1 times negative 5 plus x is not equal to, but it's, now you see x minus 5 there. And so now, if I just turn that around, that's minus 1 times x minus 5. And then you see x minus 5 and x minus 5 is a factor on both sides. Oh. They differ by factor negative 1. So I can cancel that and that, but then make sure that I multiply the top by negative 1.
Now there are 3 groups that are all crossed.
Yeah, so the only things that's left is this 2x and that negative 1 there. Okay, I think I was looking at some of your work today and there was not a negative 1 on top. So if you're that person, be careful. I like that. So this is equal to negative 1 over 2x. All that mess of stuff is just equal to negative 1 over 2x, and that's it. Okay? And so that's done.
Is it?
Finished. Done? Final answer. Yeah, I'm quite confident that's correct.
Finally.
Now, in this case, we're subtracting. So when we're subtracting fractions, we need to create a common denominator.
Wait, if we're subtracting, then why are there plus signs?
Oh, well, these trinomials, honey, contain addition. This binomial, it contains addition, but we're subtracting this piece from this piece.
Oh, I didn't see that.
And honey, I got students at home right now that are like, that was a good question. I hope she stays around for more videos and asks more questions. That was good. X squared plus 9 plus 18. I want numbers that multiply to 18 and add to 9. Sorry, guys, but this is just like, I don't know how to show you more steps than I just know those numbers, 6 and 3. I can show you how to find them if you don't immediately know them.
Really?
Okay,
you only know 6 and 3? Well, if you count 1, 2, 3.
Multiplies to 18, adds to 9. Always start your search here with the multiply one by doing a factor tree. 18 is 2, 9, 3, 3, right? There's your prime factors. You want to group these prime factors together to add to 9. And so you could try 2 times 9, but that would add to 11. You could try 1 times 18, but that would add to 19. Or you can try 6, which is these two grouped together, times 3, which does work. Hooray! Okay. Hooray.
Hooray.
That's going to be minus, so this is 3. This is minus 7x over x plus 6. So at this point, we're ready to state our restrictions. So we can say x is not equal to negative 6 or negative 3. That's because negative 6 would make that 0 and negative 3 would make that 0. We can't have that in the denominator. This one over here, x plus 6, doesn't add any or more restrictions, so that's fine. But then we notice that we need a common denominator. This toddler is jealous of that toddler's toy. That toddler has an x plus 3 factor in the bottom. So let's add the x plus 3. We're not adding it, we're multiplying it in.
I'm not a toddler.
Top and bottom. No, you're not.
Why did you say I'm a toddler that has toys?
I did not say that you're a toddler, honey.
Oh.
Yeah. I said toddlers are jealous when other toddlers have the toys that they want. And now both the toddlers have the same toys, so they both can now play. Now we're just going to multiply this in. 7 times x is 7x squared, and 7 times 3 is 21x. So this is going to be equal to 3 minus 7x squared plus 21.
Oh, my mom's calling me.
Okay, I'll be right up to read you stories.
Thanks, Daddy.
Or maybe it's a little late. We'll see about stories. All over x plus 6 times x plus 3. Now, let's go. So we see that we have, this is equal to negative 7x squared minus 21x plus 3 all over what? Oh yeah, x plus 6 and x plus 3. And that's done. Final answer. All right. So that's how you add or subtract, multiply or divide these things. Multiply is, just often I'll probably give you another like cancel fest like this where there's so many things that cancel. Dividing, the only difference with dividing is that you have to flip and multiply. Okay. With adding and subtracting, we're looking at a subtraction example where the only thing is we're subtracting all of this stuff. So you have to make sure that whatever was on top of that fraction ends up in a bracket and you subtract the whole thing. Notice that like the signs of both of these terms flipped, not just one of them, both of them. Okay. And that's add, subtract, multiply, and divide rational expressions and state their restrictions. Any questions? Email me. Otherwise, bye for now, everyone. Oh, where's my bye for now button? Here it comes. Okay, bye.